In this video, we're looking at various properties of indices. Now let's take a look at the first question. We have 638 to the power of 2 multiplied by 638 to the power of 3 equals 638 to the what? So this looks quite complicated, but actually we can do this without a calculator. We don't need to know what 638 to the power of 2 or 638 squared is. We don't need to know what 638 to the power of 3 or 638 cubed is. Those are going to be very huge numbers. But we're not interested in the value of this product. All we're interested in is finding the index here. So let's think back to what these powers actually mean. 638 squared is 638 multiplied by 638. And then we need to multiply by 638 cubed. That's 638 multiplied by 638 multiplied by 638. And I don't need to work out what this is to spot that this is 638 to the power of 5. I've got 1, 2, 3, 4, 5 of this base number being multiplied together. So it's 638 to the power of 5. Pause the video and have a go at question B for yourself. Hopefully you've spotted that 3 to the power of 7 multiplied by 3 is simply 3 to the power of 8. Let's just pause and have a look at what's going on here. In both question A and B, we're multiplying two powers, and in each question we have the same base. In question A, we have 638, and in question B, we have 3. When you multiply two powers with the same base, then your product will be a power with the same base, and the index will be the sum of these indices. What I'm saying is, to work out this 5, all we had to do was 2 plus 3. And in question B, the same thing is going on, except you might not realise there is an invisible 1 here. 3 is the same as 3 to the power of 1. Once you realise that, you can see the same rule applies. We could do 7 plus 1 to give us the 8 here. In general, these are examples of this index law in action. All this is saying is that when you've got two powers with the same base being multiplied together, you can just add the indices and write them with the same base. Let's move on to question C. We have 97 to the power of 6 all to the power of 3. And we want to write this as a simpler power of 97. Let's treat this as our base and raise it to the power of 3. So 97 to the power of 6 raised to the power of 3 is just going to be 97 to the power of 6 multiplied by 97 to the power of 6 multiplied by 97 to the power of 6. But I know what 97 to the power of 6 is. It's just 97 times 97 times 97 times 97 times 97 times 97. And we need to take all of this and multiply it by another 97 to the power of 6 and then multiply by another 97 to the power of 6. If I just put those coloured highlights back, hopefully you can spot a quick way of working out what power of 97 we have. It's simply 6 multiplied by 3, which is 18. If you count all of these, you'll find that we've got 18 of these 97s being multiplied together. This leads us on to our second index law. If you've got a power raised to a further power, what you can do is use the same base and just multiply those indices. Let's move on to the final two questions. Now with question D, I'm going to go straight for the shortcut. What you can do when you are dividing powers is simply subtract the indices. So the missing number here is 8 minus 3, which is 5. Now, why does this work? Well, I can write 11 to the power of 8 divided by 11 to the power of 3 as a fraction. I can write it as 11 to the power of 8 over 11 to the power of 3. Remember, this line means exactly the same thing as divided by. Now, I could write 11 to the power of 8 out in full, and 11 to the power of 3 out in full as well. And from your knowledge of simplifying fractions, hopefully you realise we can do this. And what we're left with is simply 11 to the power of 5. What we've just seen is an example of this rule in action. Notice how this rule relates to the first one we saw. When you're multiplying powers with the same base, you can add the indices. When you're dividing powers with the same base, you subtract the indices. Finally, we've got question E that pulls together the rules we've seen so far. Pause the video and have a go at this. Here's what you should have found. 4 to the power of 5 to the power of 2 is 4 to the power of 10. I know this because I can simply multiply those indices. 5 times 2 is 10. We then need to divide that by 4 to the power of 9. Now we are dividing powers with the same base, so we can use this rule, which means we can simply subtract the indices. 10 minus 9 is just 1, so I end up with 4 to the power of 1. So that is the missing number I need to put in the box.